copy here so others will see, right? Yeah, so we will have our introductory session today to have understanding of what will be covered in the subject. Let me start recording.
Recording in progress.
I think we will continue until others join, hopefully. So the purpose of the first session is to give an idea about the breadth of the subject. And by the way, my handout is already on the LMS. You can download a copy of the handout, and also let me show that as well. So if you just go to the LMS, you will see under announcement, I had the link, but next time I will put the link here so that you won't miss it. So you have the module descriptor here, just showing typical content and the learning outcomes and other things, and also indicative content. But we will deliver these areas not in a particular same order, because this course will be jointly delivered by Mr. Kenneth and myself. So there are topics delivered by Kenneth, and there will be topics delivered by myself as well. And this is the original module descriptor, but it shows more than 2 assessments, but we will have 2 assessments, I think, this time. One covering the aspects covered by my section, also another one covered by Kenneth's section. And we will have practical sessions on various tools, which I will explain in a moment. So we'll have an idea like how this module will particularly be delivered. So if you look at the overview content, there are quite a few areas that we will touch upon and go into detail some of the areas. So the first session today is about having an introduction. So of course, we'll talk about the rubric and the overall content very briefly, and then we will go into this the software vulnerabilities and secure software engineering domain as an introductory section to OpenAI if you're not already exposed to SSC kind of areas. And in the syllabus, you also have secure software engineering methodologies as a section where you'll be, we'll be looking at the secure development life cycle. Of course, we have different life cycles when it comes to developing software, like waterfall life cycle, Scrum type, agile life cycles, and also we have DevOps. And here in particular, we see how security will fuse with these life cycles. So security become part of the overall life cycle. So basically, you will see when we go into the discussion today, we talk about something called as build security in, which means we have security activities throughout the life cycle, which would have happened differently in good old days, where we have a separate phase for security testing, which is not good enough. Therefore, we have a different approach. We call them as build security in paradigm, which I will explain a little bit today, and we'll go into quite a bit of detail in upcoming session. And also, we will be going into various security practices. When I say security practices, starting with architectural design. So architects will do the design, architectural design, but here we are talking about secure design. So how we can bring secure requirements capture, leading to secure design, and also something called as defensive coding for bringing security practices into development phase of the life cycle. And of course, we have the security testing and secure deployment and other things as usual. So in doing so, we'll be looking at something called as, let's take the point, I think is here. So by the way, while I'm talking, I'm very happy to take up questions. You can just type on the chat or you can unmute and ask anything. I'm very happy to help you. So feel free to ask anything if you need any clarification. So in the under SSC methodologies, we'll go into something called as threat modeling, because in design applications, when it comes to secure design, and development, we talk about something called as threat modeling, where we create something called as misuse cases. Of course, we are used to, when it comes to developing software, use cases. So in the same use case, on the other side, we can model how potentially a malicious user can compromise the system or our use case. So we will do misuse cases and also a good old notation, data flow diagram, but we are using it for a different purpose. So more or less the same kind of notation, not for designing and analyzing systems like good old days, but we use a very much similar notation to do something called as threat modeling. So there are two tools, very popular tools. One is Threat Dragon, which is open source tool. The other one is Microsoft Threat Modeling tool. So during practicals, you'll be exposed to create threat models for different applications. So we'll practice that, and also that will be part of your coursework, to be able to apply and get that understanding. And we will also look at other aspects when you go into threat modeling, the assets. When you say assets, can be an information asset like the customer database, so PII, personally identifiable information, previously related data, or maybe physical assets like servers or whatever. And also threats, attacks, and also I mentioned already the DFT, data flow diagrams, were used in 1970s, good old days, for a different purpose. Because it's so easy to understand the notation, it has been adapted. I would say adapted because it's not the same, slightly refined version with newer notations. Like trust boundaries are not there in good old days, but we have, trust boundaries indicating to model different application and to understand the security posture of different designs we do. And also, we use another method called threat trees or attack trees, which will show different attack vectors, how the asset on the root of your tree can be compromised. Different path, the malicious user will try to compromise different assets of the application. So, to model and visualize, to develop and design secure applications, we will have to do those kind of, diagramming to get and to get an understanding, and also to communicate to others. When I say others, the teams, we have different stakeholders in the team, starting from the users, architects, designers, UI designers, to software engineers, to whoever. So that makes our understanding clearer for getting our final product more secure. So designed by secure, in other words, sometimes we promote like that. And we also look into something, a pair of acronyms called as STRIDE and RED, which were originally developed by Microsoft. Which has been adapted by various other various other approaches. So STRIDE basically is a taxonomy or a classification of, it's an acronym really. I'll show in the next slide, for categorizing security threats into 6 categories, which you probably learned in other courses already. And RED is another acronym for risk, as classification. We will see what it is. Like here, I just put the extra slide because this is the content, but maybe I was referring to the 2 acronyms earlier. I will just show you what it means. So STRIDE is basically that's, as I said, 6 categories. So it's an acronym which stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. So somebody can penetrate through the system as an anonymous user and try to elevate the privileges to be the root user or super user or whatever. So likewise, these are some of the baskets we can put our threats into. And on the other hand, we have RED, which was again originally used by Microsoft, which has been adapted subsequently for other approaches, of course. So that has again 5 categories: damage potential, reproducibility, exploitability, affected users, and discoverability. So if you look at what it is, we are assessing and ranking damage, how bad it is. If it's going to, going to create some critical damage to the system if somebody exploit a particular threat. In the basket we have on the left-hand side. So them, maybe we pick one of them and we can assign ranks on a scale like Likert scale, like scale. We can say on a scale of 5, for example, damage potential, whether it's 1 or 5 or 3. And reproducibility means how easy that particular attack to be reproduced. Is it hard or is it quite straightforward? So has it got to be a novice person or some professional hacker? So we can put a scale again on a scale of 1 to 5, for example, or 1 to 3 or whatever. And exploitability is how much work is it, is it necessary to launch the attack? So you need to have special tools or it's straightforward. So you can rank them. And affected users, if that particular threat is materialized, what percentage of users are going to be affected? Everybody in the system or part of the system? So based on that assessment, we are able to assign a scale. On a scale of 5, again, you can assign based on your judgment. You can assign a scale there. And discoverability, okay, there is a vulnerability. How easy it to discover? It has got to be is it straightforward or obvious? So it's not that straightforward. A skilled person will only be able to spot that. So again, we can put a scale. So dread and strike go together typically, which was originally developed by Microsoft for threat ranking and classifications. You classify the threats into baskets, 6 of them, and then you rank each of these. So you may have n number of threats, 100, 200, whatever. So each of them we can actually assess along these 5 dimensions and assign ranks and then get the sum of that and see. So the whole idea is to prioritize them. Say if you have 100 threads, what is more urgent to be addressed? For example, so when you run through a tool, you may get so many threats that you can identify vulnerabilities. So which one is more important and which one is less important? Through this kind of ranking system, we are able to do that. So we'll go into details later at a subsequent lesson. So we'll learn how to do that. If you're not done before, be useful, I think. And also we'll be talking about secure design, because when you find security bugs and when you drill down to the root cause, and most of the time, the research shows they are due to the design flaws, the architectural flaws. Because of that, it uses security flaws. So if you have a bad design, that leads to a lot of problems later. That's the basic idea. So we will look at secure design principles later, and also secure coding practices. To have a secure system, we can use set of, there are commonly developed guidelines available, for example, to make sure that the code you write is not just functional, they are secure. Because when you're given the use case or the requirement, we can convert that into a piece of software. The question is what you write, whether it's secure. So when the developers are trained to do defensive coding using these guidelines, the final product they deliver is relatively more secure. That's the basic idea. On top of that, we will also be looking at the process models and standards. Like software engineering process models, there are security specific models. Like in particular, we'll be looking at something called as software assurance maturity model, OpenSAM, and also build security in maturity model called BSIMM. This was promoted by a leading security expert called Gary McGraw, which I will refer later. He has written a book as well on secure software. And also there are other process models like common criteria for IT security evaluation, and various standards available. So we will look at some of the prominent ones. So to give you some understanding on the significance and how to apply that in real world situation. So secure porting guidelines, as I said earlier, is one area we need to learn, and also security testing. So that is part of them, various stack overruns and heap overruns and various kind of issues we can test, through various tools. So during practicals, you'll be exposed to some tools in two areas, mainly in the section I am covering on threat modeling and also um, um, security testing area as well. And also deployment. Well, we can imagine that you apply all these security practices in developing the system, and you have a relatively secure piece of software. But if you deploy that in an unsecure server, your deployment is flawed, then we open up backdoors and we expose the system, right? So secure deployment is also part of the life cycle. Despite you build a good software, but if it's sitting on an unsecure server, we know there are problems. So that's part of them, and I will talk about it. And also we'll see how these phases are integrated into secure software development life cycles. So we look at how DevOps, Scrum type life cycles, and also traditional life cycles infuse security into the whole life cycle. These are some of the areas that we are discussing as part of our lesson. And security response or incident response is, of course, when there's a security breach, the processes we need to look at very quickly, look at them. And security matrices and code and resource protection is another area we will be looking at. And so this is like indicative content, high level picture of what we'll be learning. So some sections will be covered by myself and some other sections will be covered by Mr. Kennard. And we have resource persons for helping you to do hands-on practical activities which are useful for your coursework or the assignment. So that's our, breadth of what we are going to learn in this particular module. And when it comes to assessment, we have 60% for the paper and 40% for the assessment. So continuous assessment or assignments. So we will have 220 each, I think, which we will release soon. So you can start preparing. As you learn, we can start doing things as well. So make sure you get the best out of our practical sessions, so that will make your life much easier and straightforward to do some sections of the assessments or assignments. And as for references, I think this is a typical reference we use in this field. The case after engineering section of the course, written by this leading person called Gary Magro from Cigital. He's from Cigital actually. I think he's still there. It's a good book to look at, and you can download. I think the PDF is available. You can just skim through to get an understanding of what we talk about in the course actually. So there are various other books. Those who are interested, I will just put some. You can see this is Gary Magro's book. It's a very interesting book. You can have a look, and there are other things on threat modeling and secure software. These are some of the examples. And this particular article I found useful for a beginner who want to learn along this dimension in the security domain. Let me just quickly show that as well, maybe what it is. Like not a recent one, but that's a good eye opener for a beginner. So that's why I handpicked that particular article. So it's from Department of Defense, the software tech news, secure software engineering. So I'm using some of these diagrams in the discussion. So it's a good start for a beginner to have a look. So maybe it's worth looking at. And one thing I forgot to mention was it's like a short white paper basically. So one thing I forgot to mention is in my notes, there are links like this here and there. I have particularly handpicked which I think is useful for learning this subject. So make sure you go through them when you have time. They are specially selected to help you understand better. So reading them is useful, right? Starting point also. So this is one of the reference, and there are, in addition to that, I have handpicked few other references which you probably already looked at for other courses on secure software development domain, and also few other reports that are particularly useful for understanding this better. And also this famous place OWASP and CEW, common weakness enumeration kind of links are useful. I'll be referring to some sections of some of these reference like CEW, for example. So the first one is like a open web application security project, which has quite a lot of resources for a person who want to learn this subject, right? So cybersecurity. And also this is another CEW or common weakness enumeration is useful for understanding and managing software weaknesses related architecture and design. So later we'll talk about if you do a good job on developing the software and deploying in a secure way, then we are covered to great extent, right? So this is what you need to look at. Now, as I said earlier, during the practicals that we do, you will be taught or you'll be trained on using some of the tools. And here we have some of them that will be covered in your practical. The first two is actually on threat modeling. First one is Microsoft Threat Modeling tool, which will help you to create this DFD notation based threat models, um, which will help us to assess and identify trust boundaries and potential problems that when you create the whole application. So that will be a very useful tool to communicate and understand the security posture of what you're doing when it comes to building systems. Second one, again, is called a Threat Dragon. It's an open source tool doing very similar work like Microsoft tool. So you have open source tool as well. They have their own little plus and minus as usual. So you'll be taught how to use those tools to do threat modeling, because you need to create threat models for given scenarios. Right? You should be able to. So given a scenario, a text, can you model? Can you create a threat model using one of these tools? Is one of the skills we expect from you. Therefore, being familiar on one of these tools is, a small skill that you will acquire from the course. And also you'll be using for some of the practical find SecBug, SonaLint, Sync, and SonaQ for other practicals as you go. Maybe you're already familiar with them. Some of you may be already familiar. So those who are not familiar will be useful for you to get the hang of these kind of tools. So these are some of the tools that you will be exposed during our practicals. So that's the picture of what is going to be covered, the kind of tools that you're going to learn, how you're going to be assessed in the final module assessment rubric, and also indicative content like high-level picture of the topics that we'll be covering. So in the next couple of slides. I would like to take you through on an introduction to security, software vulnerabilities and secure software engineering domain. To open your eyes, those who are not familiar, this will be very useful. I think it's a different perspective to security actually. Just to put a snapshot of the gravity of the problem. So this is October 2024 from this site. Attacks from different, different perspective, malware to ransomware, targeted attack, DDoS scams, and various type of, top 10 type of higher, most frequently occurring attacks actually. So we can see the percentage, for example, malware taking 26%, and then the ransomware 14%, likewise. So this is just to get a understanding of the gravity of the problem. And also the second snapshot is just to show you again from the same site. As of 2024 October, the different sectors being affected from different industries, individuals, finance and insurance, education, fintech, and various. You can see targets being made by different hackers basically. So just to recap, refresh your memory, I'm sure you'd have learned some of these basic things I talk about at the very first couple of slides. Just to refresh your memory. So what is a security vulnerability? Well, it's a specific weakness or a flaw or a weakness basically in a system that can lead an attacker to compromise the system. But when you say flaw, it's basically a broader kind of a meaning or a term. That will include any weakness that may or may not be a security implication, because when you have weakness that may lead to a security flaw, can lead to the flow can lead to a security problem, or it doesn't necessarily have to be. So security vulnerability basically is an unintended feature in your system that will cause problems, right? So these are just preliminary things that you need to refresh your memory, because I'll be using some of these terms in the upcoming slides. But how do they creep into our systems? The next question is, okay, we know there are vulnerabilities, but how do they, different ways that they can creep into our systems? So it can be due to in-house negligence, or it may be due to external oversight. So there are a lot of things we can think of. Here's just a sample showing the gravity of the problem. So they may be due to the vulnerabilities in the they may be due to the vulnerability in the source code. This is one of the areas you'll be looking at. If you introduce vulnerabilities into your source code, that will lead to security problems later. So through secure software engineering, we are talking about secure requirements capture, secure requirements capture, secure design. Architecture has to be secure, and defensive coding. So we bring security practices to software development, and also security testing plus secure deployment. So that will reduce the possibility of having vulnerabilities to some extent or great extent based on the rigor. That is part of the problem. So vulnerabilities can, of course, creep through the source code, and it may be due to misconfigured system. So like I said earlier, you may build a good secure piece of software, but if it's sitting on an unsecure server, then the software is exposed, right? So misconfigured system components can lead to issues, and trust configurations can again lead to similarly, open up vulnerabilities, and and also weak credential practices. Some of the applications, when you look at the credentials, they are too simple and it's very easy to penetrate through, right? So weak credential practices can be an issue, and lack of strong encryption obviously is another problem. Insider threat. So sometimes your own employees can be a problem when it comes to security. So that can open up security vulnerabilities. And in addition to shared tenancy, insufficient monitoring and logs. So if you don't monitor and maintain the logs, you may not be able to notice that things are going wrong, and then you end up with problems. So sensitive data exposure, different forms of injection. So later in the course, and probably you are already exposed in the first year on various tools in handling different forms of injection flows. And then insufficient authentication obviously is another issue that can, allow vulnerability to creep into the systems. And social engineering related vulnerabilities is another one. When I say psychological vulnerability, we are referring to social engineering related vulnerabilities. So this is just a sample of ways that obviously, vulnerabilities can creep into our systems from different points actually. So surely you can add more from experience. And when you want to make systems secure or secure software, for example, we talk about reducing the attack surface. When I say attack surface, this is like a possible points like vectors. So collection of vectors can form a surface, in the typical sense. But here we refer to the same, use the same kind of terminology to explain the attack surfaces. So attack vectors can form a surface in a way. So there are various points. An unauthorized person can exploit the system vulnerabilities. So when you have vulnerabilities, they can compromise them and then come to the system. So there are various parameters and data types and attack surfaces classified into different areas like digital attack surface, which is what we are interested here at this point. And also there can be other physical attack surface and social engineering attack surface, which we can analyze separately. So in the first part of the discussion, we'll be looking at the first one actually, the digital attack surface and how to reduce that through bringing security throughout the life cycle. That's our discussion in the first handout to some extent, which will continue to some extent to second handout as well. So we can have various points. So these are like vectors, right? We can have different attack vectors, like out of date SSL certificate can be an example. Weak company website, security in terms of security, stolen employee emails, or it can be stolen employee password or something like that. So this is the surface, like it's trying to illustrate from a picture actually. So this is the surface we are talking about, and we have different attack vectors, different ways that can allow the attacker to exploit these vulnerabilities. So when you talk about the domain of secure software engineering, we know it's a great problem because the defects can be unintentionally introduced, so without your knowledge, and creep into your design and development. Like I said earlier, when you have design flows, that can lead to security problems in your system, in your application. So when you do security testing, you find out the problem, and when we do the analysis of the root cause, it will drill down to the original design where there's a design flaw. So fixing design flaws is very expensive, obviously. So we need to think about how to minimize them at early phase of the life cycle. Because in the good old days, the approach was build and patch. We don't think much about the security at early phases like requirements capturing, design, and coding. And once you have the artifact or the piece of software, we do security testing and identify the problem and try to fix it. In order to fix the problem, sometimes we need to do structural changes of the code, which is very expensive and time consuming. That's where the key use case is, or the requirement is that we are trying to get at slowly. So we need to reduce the software vulnerabilities and overall defect content in early phase of life cycle. So that's what we are slowly looking at. So therefore, the people have realized that we need to integrate or fuse security practices throughout the life cycle so that we gradually build a relatively secure piece of software than the traditional approach. So therefore, we have these secure software development life cycles, whether it's DevOps or whether it's agile, whether it's waterfall or whatever traditional, we can do that. So I will show you some examples in the upcoming slides. So if you look at the how we can try to filter and try to remove these vulnerabilities, there are different points we can think about. If you zoom in a little bit, so requirement activities. So we capture requirements. There are some percentage of vulnerabilities injected during requirement activities. So that can be removed through a filter. So if you don't do the traditional requirements capture, but rather you apply the practices of secure requirements capture. Um, so you can, remember we talked about tools like threat modeling tools like use cases. So when you want to model the use case, we have certain notation. So in the same diagram, we can draw how the malicious user on the left-hand side, let's say, you model how the legitimate user will, use our system, say it's a banking application, logging in and we, doing various transactions. But in the same diagram, we are able to model how a malicious user may compromise system, like, doing a dictionary attack and trying to penetrate through the system, for example. So it's a combined diagram of how a legitimate user will use this particular use case. At the same time, how a hacker would try to compromise our use case. So later we will talk about them with various diagrams and examples, how to create use cases and misuse cases. Of course, you probably know how to create a use case, but we'll see how to bring this concept of misuse cases or abuse cases to model some of these things. So we do activities like what we are going to learn in the practicals like threat modeling or abuse cases or misuse cases. So we have the use case and also we model the abuse case. So we know how things can go wrong. So when you do the design, we can consider this abuse case. When you do the development, this misuse case or abuse case is useful. And when you design security test cases, your test cases later, this become an input. So what we create at early phase of life cycle become useful in terms of design, development and testing phases subsequently. Then we have the design activities that we usually do with our applications. And we can have filters to remove some percentage of vulnerabilities injected during the requirements and also design activities. So there are activities we will learn later, we'll discuss later, like the design reviews and verification methods that we can use. So when you do a design, we have an activity called design reviews, like code reviews you typically do in development. We can have secure design reviews, which you look at whether our design is secure now. Because if you do a system design which is weak in terms of security, that can lead to a weaker or in terms of security, a weaker piece of software, which will lead to problems later. So we look at the downstream processes and then we look at the life cycle. We will learn how to do this with examples in the upcoming discussion. And when you do implementation activities, again, we can have filters. When I say filters, what do I mean by filter here? Filter is our threat modeling, for example. When you do threat modeling, we are able to identify problems. When you draw abuse cases, you are able to identify and visualize the problem, and that become an input to the next phase, design phase. An abuse case can be an input to your implementation. Because what you noted there, if you see how a dictionary attack is possible for this particular use case, when you do the coding, we train the coders, developers how to do defensive coding or secure coding, how to use secure coding guidelines. So what you do here will be relatively more secure. That's what you're looking at, right? Um, so so when you have these kind of filters of in terms of security, so we can filter possible vulnerabilities that can creep into our system during requirements capture, during design, during implementation, and of course we will do some activities in testing and deployment later. So this is coming from that document I showed you earlier. Earlier, I think I showed you that website. When I say the document, I'm referring to actually this one, this one. So read through this document to start with. That will make your life easy when you want to understand our first part of the discussion. Going on, yeah. So I said we need to have security activities throughout the life cycle. At a very simple abstract view, this is what we can see. So when you want to address security throughout the life cycle of your software, when I say life cycle, this can be DevOps, it can be uh, because when you say bringing security practices into life cycle, that life cycle model can be DevOps, it can be Scrum like agile life cycle, or it can be waterfall like traditional life cycle. That doesn't matter. But when you look at the phases of requirements capture, design, and implementation and testing for QA activities, there's a role to do. There's a role to be done actually. So what I'm getting at is later you will see we are talking about security become everybody's business. What do I mean by that? Well, there's a role to be played by the requirements capture, engineer doing the requirements capture, and the software architect, software engineers, QA practitioners. So everybody in the life cycle has a role to play. It is not the specialized job of the security expert anymore. We need them, of course, but we do train um, the team, basically starting with the architect to software engineer to everybody, about this new paradigm of doing security throughout the life cycle and their role in doing the activity, like defensive coding for a software engineer. So he, of course, may be experienced software engineer, but whether he apply defensive coding guidelines or security guidelines when they are coding to make the code secure is a different question. There may be experienced architects who pay less attention perhaps to security, but here we are talking about an architect who's looking at secure design. So likewise, so requirements capture can be augmented by creating use cases. So during requirements capture, one might create use cases. Typically, we do that, right? We can do that. And the same use case, we model that use case. So what do I mean by that? Well, let me just show you an example if I can find something from the just give me a moment. One will be useful, I think. So what do I mean by abuse case? If you look at this diagram, you can see we have a use case, typical use case, that is the legitimate user. So we have a waiter and cashier and client, in typical use case, but the black side is a misuse case. So we have a hacker, this is an analogy, of course, trying to steal food, then steal wine and steal, payments and whatever. So that's the wrong side of it. So of course, this is just analogy, but I can show you a better one. Maybe let me show you a better example from a banking or some other context. And we try to find something that will be, yeah, there are plenty of examples you can see. So you can see again, we have the use case on the left-hand side and the misuse case on the right-hand side. So we can look into abuse cases at requirement stage. So we know early stages how things can go wrong. Therefore, when you do the design, we can do better or secure design. We can do, so if we have the abuse cases that become input to your design, and those abuse cases can be input to your implementation as well, and also for generating your test cases. And in the design phase, we do other activities, like I said earlier, something called as threat modeling. So using the Thread Dragon or Microsoft Thread Modeling tool, for example, we can create thread models of the whole design to understand something called as trust boundaries. When the trust level changes from public network, which is internet, to the periphery of the network that we are accessing in the server. So there's a change of trust. So we can model that. So we need to see what precautions we need to bring in, like whether hardware security or software security when you do the final system. So during design, we will be doing threat modeling, like I said earlier. Uh, Threat modeling is one thing we need to do. Let me show example. Maybe later we'll be looking at in detail. Let me show you example that to make for those who are not familiar. Let me see whether I can have something for you to. Yeah, maybe this one is useful. So we can see here. We can see how data flows through the system at different systems. So we have databases, and systems may sit in different networks, for example, at different trust levels. So here, maybe somebody accessing from public network, and when you have a particular territory of your network, there's a trust boundary. So the trust level changes from this side to that side. And maybe this part of the system sitting on another uh, network or security layer. So we have another trust boundary. Maybe your database is sitting in another server, another network. So that's another trust boundary. So likewise, we create threat models like this, for example, to understand and use them to build better systems, right? So and so we will. So apart from doing threat modeling, we will also do apply secure design principles. So like coding principle, there are secure design principles, which I will show you from OWASP and various places. You will find quite a lot of resources for them. And also security feature design, authentication, authorization, likewise. We can bring security features into your design, right? Because we know from misuse case, this is say, if there's weak authentication, there's going to be a problem. So we bring, something for that. If there's weak encryption, then we can see from our abuse case here, somebody can compromise it. So because when we create a abuse case here, we see if we have weak um, encryption, that's going to cause problems later. So when you come to this stage, we know we have to bring strong um, encryption for this particular application. And also we conduct like code reviews that you typically do as software engineers maybe. We do design reviews. So we review the design and see whether we adhere to these guidelines, how well we are doing. So we can do brainstorming likewise. So likewise, there are various activities that you see in this purple color block. Things to be done that is not typically done, right? When you do typical software development, maybe they are not done. You don't create abuse cases. You may only create use cases. You wouldn't probably create threat models. You may just do the design diagrams, UML diagrams, right? And when it comes to development or implementation, like I said earlier, secure coding guidelines and conducting code reviews and using various tools for static code analysis and dynamic code analysis. So we'll be exposed to some of the tools for analyzing code. So you can conduct static code analysis and dynamic code analysis of your code to make sure that the piece of software we write is secure. So it's not just converting the use case into a piece of software. We're looking at how to create a secure piece of code, which will do the job that is supposed to do. So it's not just a functionality, a secure functionality that is to be offered from the application. The next thing is, of course, we have to do security testing as usual, which will include different forms of testing. So lots of different testing and also the use of test automation tools. There are quite a lot of test automation tools starting, JMeter to whatever, we can see long list of Selenium type suites. There we can have a lot of tools for grid-based testing and whatever. Web front-end testing. So we can use various tools and have proper test plans and do that. So you can see here there are certain activities that are not very much familiar with traditional life cycle. We will bring into the secure approach. So like we have seen already, so we have requirements. We may do secure, planning, looking at security, and then secure architecture and threat modeling related activities happening there. Security code reviews, following defensive coding guidelines, conducting various testing, and reviewing the attack, the attack testing and whatever you do. And then final security review and response. So the response is what? So basically we capture requirements, you do a secure requirements capture, secure design, secure implementation or secure development, secure testing, secure deployment, and something called as incident response. So we should look at the process of incident response. If we have done a good job, maybe, but still there can be vulnerabilities which are not exposed to us. So therefore there can be incidents. So in the case of an incident, how do we respond to them? So we need to have a process for that. So we don't forget about until things go wrong, it's part of the life cycle. So you'll see later, it's like an augmented kind of extended version of typical life cycle phases. So you can look at some samples like from a local organization I just found. Sorry, that I found interesting. So you see how these are practices to in different levels at different organizations. You can see from a local organization, secure software development process, how it's going, what we are talking about here from secure design review and, developer self-review to code review in terms of security, right? So there are various security tools and practices brought from other domains, and they have developed their own guidelines as well. So during the design phase, there are things to be looked at. What are the interactions with other components or other application building blocks through web services or whatever, or middleware, and how those interactions will happen? Because sometimes when you look at some other the air ticket, airline ticketing systems and whatever, perhaps some of the components of the application is sitting on legacy applications like IBM AS400, RPG 400 or whatever. And from the phone, we are booking a, air ticket, but we are looking at, contemporary Android-based application talking to some legacy application in the far end. So likewise, we may have to look at how the overall application is going to be integrated to different building blocks, and what are the access and trust boundaries of the component. I refer to trust boundaries. In that diagram, I show you that dashed red line. And who should be able to consume functions exposed to the component. So likewise, there are various questions we can ask. And also, when it comes to development phase, there are things to be done. So you can literally look at this, these things I showed you. So there are some mandatory checking during the release. Because when you do deployment, there are mandatory things to be done. So your application is relatively much more secure than a traditional. I found that as an example, so I included that as well. And also we have this. This one is also again useful, I think. There are some sections I found useful for a beginner. Just to have a look at them. So when you look at key development security risk, it can be legacy software, poor, quality code, systems that are not maintained, and how you store your passwords, and web service vulnerabilities. And you have web services, if you're not careful, you can be exposed, right? So there are some useful reading there. So that's another link I would like you to look at. And if you look at this top 10 project, it's a useful one again from us. Um, maybe you're already using these, information repositories for various purpose, but at least those who are not uh, familiar with them, I would strongly encourage you to look at. So there will be new release in the first half of 2025. So top 10 application security risk, from 2021 to 17. So quite a lot of useful resources there. So then it's worth looking at those hand-picked examples and reports that will relate to what we discuss here. So we talk about threat modeling and abuse cases and using various tools to make your application secure. Therefore, I think this additional reading is going to reinforce your understanding, right? And also this National Vulnerability Database, NVD, from US government report. It has quite useful information on stamp-based vulnerability management data, which can be used for automation of vulnerability management, security measurement, and compliance. So it's quite a useful link to look at. So what we discuss in the lesson will have, when you look at the real world scenario, these links, let me show you very quickly again, so that will make sense actually. Okay, why are we so concerned about some of these things? If you look at this report, there are quite a lot of information that will relate to what we discussed, right? So that's another one. And also there's something called vulnerability nodes database, another database. So there are various resources that are useful to what we talk about here. So reading some of them will make your life easy to understand. Now, there are various information reports that will help us to bring this process into organizations. So one of those is this CWE, the Common Weakness Enumeration. Is a commonly developed, commonly developed, like a, it's like a forum that is developing a list of common software and hardware weaknesses, which can be used to bring enhance our knowledge in creating secure software, secure applications. So when you say CWE, they are referring to weaknesses like can be related to software, can be firmware, it can be hardware, or even a service component. It's a holistic picture actually. So if you know the weaknesses in advance, you can eliminate them before deployment, which can cut down the cost. So just trying to illustrate here. So if you have plan and analyze, design, commerce capture, design, develop, or implement, test, deploy, and maintain. So these are typical phases, right? So you can see here, during design and implementation, weaknesses can be introduced. So if you are not using secure design guidelines, your design will have architectural flaws, for example, which can lead to coding issues or develop weaker code, which will lead to security bugs later, right? So there are 2 points that can creep in. The problems, weaknesses can creep in during design phase as well as during the development or implementation phase. Now, when do we discover? Well, when you go to deployment, some of the vulnerabilities are discovered. So when you deploy, we see, oh, well, we have security bugs here. Or even after deployment, certain incidents happen, security incidents happen. So during maintenance phase, you will discover the vulnerabilities of your system. So, so if you look at the bottom here, we can see this is trying to indicate the cost factor actually. So as you go down the life cycle towards this side, the cost become much more. If you fix the problem at design phase and implementation phase, the cost to fix them at that stage is much more less compared to trying to fix them during maintenance phase, for example, right? So So both this development community and the security practitioners, they are one of the key goal is to reduce the vulnerabilities, and um, so CW is trying to educate the different stakeholders of the life cycle, which will include the architects, the designers, UI designers or whatever, and then software engineers who convert the design into a piece of software, for example, and also acquirers, and how to eliminate most common mistakes. So basically, if you look at the problems we face when it comes to security, these are not new. I mean, they are faced, this problem is faced by so many people around the world. So if you know these are the most common mistakes people tend to make before you deliver the products, then we can take precautions. So this CWB will help the development community as well as the security community, practitioners to do a couple of things like describe and disguise the common weaknesses in a common language because a common framework, right? And also check for weaknesses in existing software and hardware and firmware, for example. And evaluate the tools, basically. There are various tools and we can evaluate through their framework actually. And also leverage a common baseline standard for finding out weaknesses and bringing in mitigation steps. When I say mitigation, how to counter them. So we find a problem, what methods of solutions are available, what kind of mitigation, because when we find security threats or vulnerabilities, we can do an assessment and put these, say there are 20, we can put into different baskets. Some of them are not that much of a problem. You put into a label of 0, let's say, and there are certain problems which are critical. So you put into a label of 5. So there are 5 baskets. What is in the box 5 is critical. And what is in the box 0 is less critical, or they are not that much impactful, right? So maybe they can leave fixing these problems to the next version of the software, for example. The mitigation decision can be in different ways, transferring to a third party, if we are acquiring different building blocks to build a system, or fixing the problem if it is possible, or deferring the issue until you go to the next cycle or the development, if it's not that much impactful. So we should have a mechanism to prioritize things. So when you run through a tool, it may give hundreds of problems. Now, if you have a method to prioritize them, like rank them, this is first top 10. This is the next 25. So we know the top 10 is more critical. So we will, when it comes to mitigating them, when it comes to fixing the problems, we start with the most critical one, right? So we learn how to do that actually when you go to the upcoming discussion. So and also to prevent the vulnerabilities prior to the deployment is another thing we can do. So this CWE will help both development and security domain practitioners to address the problems that we discussed. So this other one is, this is a common weakness in enumeration. So we also have something called as CWSS, which stands for Common Weakness Scoring System. That's a different, again, a community-based effort like the previous one here, CWV. It's a different one actually. It's trying to look at the needs of stakeholders across the government, academia, and industry. So because we have weaknesses discovered when you run through tools. So how to handle them again? It's a different approach, but there are similarities, right? So the CWV, the one we discussed earlier, for example, you can see it's getting input from various domains, like for example, publicly available security taxonomies, research and checklist will be fed that in the development of CWV consensus, right? And also other available security taxonomies and research checklists like units from different vendors or different industry, leading people like Unisys to, Oracle to whatever. They have their own checklist and various research they have conducted. So that will feed into this development of CWV. And of course, initially they have this the legacy taxonomies which has evolved over the years, and then that will feed into the thing we just discussed, the OWASP report providing various guidelines related to that. So it's like this is the big picture actually, how it evolved into the current state we have seen. We will just hold on for a couple of minutes, like 2-3 minutes, and continue. We will just maybe another 3-4 minutes, and we will continue. In the meantime, maybe I could play Gary Magro's video. We have to stop sharing and reshare with the sound. I have already shared sound. Let me try to find that. I think this is the one. By the way, can you hear the sound?
Okay, I'm very pleased to have.
Okay, thank you.
Dr. Gary McGraw join me today to talk about software security. Gary is the Chief Technology
I will
Officer
not run the whole video, it's quite long, but first few parts we'll have a quick look.
at Cigital Incorporated, which is a software security consulting firm that provides services to some of the world's best known companies. And Gary is a highly regarded expert in the field of software security, having written or co-written 6 best-selling books and more than 100 peer-reviewed scientific articles on the topic. He also hosts a regular podcast called The Silver Bullet and writes a monthly opinion article that has found its home in many publishing houses over the years, but is currently at Search Security. Gary is also on the advisory boards of many companies and universities, and in fact, he serves on the advisory board of the Maryland Cybersecurity Center, which is a nexus of cybersecurity research and education here at the University of Maryland. Well, Gary, welcome. It's really great to have you here.
Thanks.
So can you tell us about how you got involved in computer security, maybe a bit about your background?
I got started about computer security for the first time. Now, this was really 1995. And at the same books on software security at the time. So I wrote Building Secure Software with John Viega.
Have a better video. It's quite a long one. That's a better one, I think.
Hello guys, welcome back to the channel. So first of all, just
I think in my note I have that link. I wanted to quick preview. This one. Better one. We quickly find out that oh, I think that has been made. Okay, anyway. Anyway, I think I'll let you check offline slowly. Just hold on for 2 minutes. Right. So we have seen the CWSS, and also there's other, there are a couple of initiatives actually by different forums or consortiums. So this CVSS is another one, which is widely, used framework. And this is for classifying and rating software vulnerabilities. So they have their own emphasis. You can see we have seen CWE, CVSS kind of stuff, your approaches. So community-based initiatives, and they have their own emphasis, although they are in the same line of thought, I would think, right? So this is an open framework again, and this helps us to calculate something called as a CVSS score. So we can go for a numerical score that will assess the severity of a vulnerability. Because as I said earlier, sometimes what happens is when you run through a tool and try to find the vulnerabilities of a piece of software, you will end up with maybe a couple of hundred sometimes. So the question is to identify what is more severe and what is less severe is one of the aspects we need to do, because when it comes to fixing them or mitigating them, we should have some priority. So some of the frameworks helps us to look at from that angle. So here is just another initiative. So there has been since 2005, this has been there but the latest release is actually version 4, CVSS version 4, which was released in 2022. So over decades, this has been around and this has been a useful framework when it comes to this domain. So some of the links I just put here from IBM's perspective, and this is this non-profit organization first.org who has taken over and developed this CVSS4 version 4 actually. So you can have a look at them. The link to the specifications also here, right? So I will not go into a lot of detail, but we look at and try to compare those leading ones. There are so many initiatives, but we have selected the dominant ones like CVSS, CWSS. So we try to compare the two we just referred. The CVSS, or the Common Vulnerability Scoring System, as I said earlier, is basically a common method used by the security domain practitioners, and it will measure and score the severity of a vulnerability. So measure and score. So you can assign a score through this framework. So that will help us to prioritize, right? And on the other hand, CWSS, or what we call as Common Weakness Scoring System, is again a scoring system that can be used to identify and prioritize software weaknesses and most likely to be exploited by the attackers. So they are pretty much similar, but they have their own plus and minuses, as you can see. So this one just trying to summarize an example of the features. So comparison between the factors. So CWSS has its own set of factors, and CVSS, this is version 2 actually. In this example, we have 4 right now. If we zoom in a little bit, you can see this confidential impact, integrity impact, availability, security requirements, the damage potential, like a couple of dimensions when it comes to CVSS. But when it comes to CWSS, we talk about the technical impact. So it has a similarity. But if you look at other parameters, you can see some are not applicable in the first one, while we have, like, for example, authentication strength. Because this one does not directly specify within CVSS, but other one has. There's a reason for that. I'll show you in a moment, right? So some are applicable to the CVSS when you look at all these dimensions. This one is trying to put side by side and try to do a little comparison. So if you look at my link here, you can see in the specification what we just say here, right? So let's take the full screen and then the pointer. Yeah. So when you try to compare, the first one, CVSS, assumes that the vulnerability has already been discovered and verified. So you have to have it ready, right, in order to apply this approach. But CWSS can be applied early in the process before any vulnerability has been proven. So we can see here the question of whether we have identified already or whether it has not yet happened. So has two different angles or two different approaches to the same kind of problem. So in other words, the first one does not account for incomplete information, but second one, has support for incomplete information. So you don't have to have the problem happened already for the second one. So if you go into detailed links I showed you, you can see this is just a snapshot of the CWSS, the second one, the Common Weakness Vulnerability Scoring System, the second one we are referring to. So if you look at the structure of the framework, there are 4 metric groups, so 4 areas or 4 building blocks. One called as base metric group, the other one called threat metric group, the third one called environmental metric group, and the final one called supplemental metric group. So you can see here, there's some progression from the base metrics to the environmental metrics, for example. So in the structural diagram, you can see here, in the matrices, there are exploitability matrices, attack vector. Attack vector we discussed earlier, if you remember. If you remember my diagram I showed you here. there can be different attack vectors forming the attack surface. From out days, SSL is one vector, stolen employee is another vector. So likewise, a lot of different attack vectors can form a surface like what we have seen earlier, right? So that is what they are referring here. So there's one area for them, and then the attack complexity, how bad it is, for example, attack requirements, what are the preconditions for this attack to happen, and privileges required. Has it got to be anonymous user, or it has to be anonymous? It has to be the admin user to carry out this task. So we need to do assessment on different dimensions and use authentication and impact matrices. How bad in terms of a particular dimension. Say, for example, the confidentiality or integrity, availability. Say, if this attack happens, the entire system goes down and nobody can use the system, versus only a part of the system is affected. So a greater percentage of users can still use the system. So we need to do this assessment to put a scale, a score, whether it's 0 or 5, as we said earlier, as an example, simple example. And also subsequent system integrity, subsequent availability likewise, right? And then we have the exploit maturity as one group, and we have the improvement here, the modified base matrices. So we have a set of base matrices here, and we have an enhanced version here, enhanced attack vector, enhanced attack complexity matrix, attacks requirements, privileges required, user interaction. So likewise, a lot of other detailed matrices you see here, right? So you can see here there are 4 main areas. The last one is about supplemental. Like when it is supplemental, basically additional matrices, whether we can automate them, and the recovery, safety, likewise. So same thing detailed here actually. There are 4 areas like I shown you in the previous slide. The first one will reflect the severity of the vulnerability, the base score or the base, and the threat matrices will adjust severity. So likewise, supplemental one, as I said earlier, use additional. As the name says, additional extra attributes of vulnerability. So that will provide some context to the assessment that we do here. So this is just one example, but if you go to the link I provided here, in the specification, you can go through and see how it can be applied to a particular given situation. So we have seen a couple of initiatives of that nature, which are mostly community-driven kind of initiatives, which has a history, which evolved. One of them evolved from 2005. Now we are talking about 2025, 20 years of evolution, right? We still use them. 2 decades of evolution as an example. So likewise, we also have this other example like known exploited vulnerabilities catalog. So we again a community driven initiative for the benefit of, so you can contribute to some of them as organizations, as individuals. So we have this as other example. So here, so far, we were looking at some of the preliminary initial things that we need to understand to go to the next stage of our discussion, like different initiatives for looking at this vulnerability issue, starting with CWE, CVSS, CWSS likewise. There are many, but these are the more prominent and more important ones in one or the other. So in the next part of our discussion, we will be looking at another key concept that we need to understand from the first lecture or the first discussion. What is this concept called as secure software? Software security is something we have seen probably in the other courses probably already. So yeah, secure information systems is what we are talking about here. So if you look at to design and build a secure piece of software, all building blocks need to be secure. all part of the life cycle has to be secure. So just the focus on perimeter security or infrastructure security is not enough. So trying to build a piece of software and trying to put them in on a network with highest possible firewall protection and perimeter security and various tools we can have, that is not going to help, because we can show you some examples where just the perimeter security and infrastructure security is not good enough nowadays to protect your information assets or servers. So therefore, this secure software engineering domain, the new domain we are referring to, we talk about, as I showed you already, doing security activities in the requirements engineering process, design process. We call them as secure design, and risk analysis, threat modeling. I showed you example threat modeling, and you will be using Microsoft tool and the Threat Dragon tool to create threat models and learn how to do that in the practical, and deploying good crypto algorithms, doing defensive coding. When we say defensive coding, we are talking about applying secure coding guidelines as software engineers. So we are not just converting the requirement into a piece of software. We are creating a piece of software which is supposed to be more robust in terms of security, because we know how to, if we apply them, your code will have less security problems. Rather than just doing it and then testing and try to fix it, we are trying to do it in one go as much as possible to be secure. Of course, it's not 100%. We can't make it 100%, but be relatively much more secure than traditional approach. So therefore, defensive coding is something that we need to look at later. And pen testing, fuzzing, static analysis, security assessment, we do anyway, but we will need that still here, right? So secure testing related security has to still happen. But if you use traditional approach, you would not do threat modeling abuse cases usually. You will still use cases and do architecture and do the development, and finally you think about security. So it's not looking at the problem late in the life cycle. We are looking at looking at that in the early life cycle. So therefore, we'll end up in two situations, whether we look at security from a proactive perspective or reactive perspective. What do I mean by proactive and reactive? Is it a question of we try to fix when things go wrong, or are we trying to avoid the problems so that we will have less or no problems? So it's a question of being reactive or proactive, right? So therefore, these two terminologies sometimes get confusing. They use sometimes interchangeably as well. So there are two terms we refer later. One called application security and software security. So one has a broader meaning, another one has a slightly narrower scope in terms of what we talk about. So actually there's a difference in our context here. So application security usually focuses on securing the individual applications by looking at and fixing the vulnerabilities within the code. So that's application security, right? We are focusing on individual application. But when you say software security, generally it's a broader meaning that we look at. It's about protecting all aspects of software, including design, architecture, data handling, entire thing we are looking at, right? So it's slightly broader. So this Gary McGraw, I was just trying to play a video if you remember, and I also showed you a book written by him. He maintains that the application security is something called as a reactive approach. When you say application security, looking at your application security, as I just showed you in the previous slide, is a reactive approach. For example, without doing secure coding or secure design, we can build a piece of software and see what are the problems later and try to fix it. Security problems I'm referring to. So reactive means when things go wrong, we try to fix it. We react to the situation. Whereas software security is a broader meaning, and he refers them as a proactive approach. So we do pre-development phases. We work on deployment phases. Before you try to deploy the software, we do things like secure design, secure requirements capture, defensive coding, so that we have less problems. So it's a proactive approach. What do you mean by a proactive approach? Before security problems arise, we try to do things earlier in the life cycle. Secure requirements capture, secure design, defensive coding, likewise. Whereas other one, we just go as traditional and then try to fix it. So that's the emphasis here. So in the book, if you look at the book and the other reference from Pittsburgh link I showed you, that will open your eyes in what you talk about here. So application security, we can say, is an issue-based short-term approach and build and patch, or penetrate and patch. So we build a software and do penetration testing and try to patch it. Is it reactive or proactive? It is reactive, because when things go wrong, we try to patch it. But on the other hand, when it comes to software security, we can say it's a holistic long-term approach. So we try to find the root cause analysis. Root cause can be a weakness in the requirements. So we create attack trees and threat models and abuse cases early in the life cycle. Right? So you do threat modeling, you conduct code reviews, you create attack trees, you create abuse cases, DFT-based threat models, likewise, a long list of things we can do. So here it's basically a proactive approach, whereas this side is a reactive approach. So it's a question of, are we trying to fix when things go wrong, or are we trying to fix problems in advance so that we'll have less problems? So proactive approach and reactive approach. So threat modeling is a common thing that we'll have to do. So high-level picture is application security, as I said just now. It's like build and patch. You catch and patch kind of approach. You build and patch the problems. And what happens is you look at the external symptoms. But in the software security, we look at the root cause of the problem and try to fix it. We don't look at the external symptoms and fix it. Like with the application security, we try to look at the root cause and try to address the root cause. Because root cause can be your architecture. Architectural flaw can lead to a long list of security bugs. The problem is in your architecture, not the code you write, right? So that's why. Example. So in the left-hand side, the application security, we said, it's like build and patch or catch and patch kind of approach. But security built into each phase of life cycle is what you do with software security. Build security in. In simple words, security throughout the life cycle. So we can say the first one is a reactive approach, because when things happen, we try to respond. And on the other hand, software security or build security in, we say it's a proactive approach, because we do that modeling, code reviews, likewise, to identify potential root causes and then address them early in the life cycle. So we said the software security, we said, is a pre-deployment activity, set of activities like secure design. So do your design with an eye on security features. So not just the architecture, secure architecture. So you build a secure architecture, so what you build or code or convert into software will be more secure. And development of secure coding guidelines. So for developers or software engineers, like I showed you from a local example, there are guidelines for developers who will follow these coding guidelines or security guidelines in terms of coding. They don't just code, they follow the approach called as defensive coding, or they follow security guidelines in coding their software. So that will lead to relatively more secure code actually. And then another example is development of secure configuration procedures. and standards for deployment. Because he said, even if you build a really good piece of software which is secure, but if it is going to sit on an unsecure server, your deployment has an issue, then the software is exposed. So therefore, it's important secure configuration procedures, which we will discuss in detail later. There are things like least privilege as an example that we use as a principle in configuring secure configuration procedures that we can apply. So we'll have a separate section on discussion later on this area on secure configuration procedures and standards. And other one we will look at later is the secure coding guidelines. Secure coding that we will have established guidelines that we can use, and also validation of user input and implementation of suitable encoding strategy. Proper user authentication, proper user management, function level access control we can implement when it comes to coding, and use of strong cryptographic algorithms, and sorry. Yeah, so these are the activities we do as pre-deployment security activities, which includes the whole list, including validation of third-party building blocks. Sometimes we build a piece of software and you integrate with the third-party building block, and this can introduce security vulnerabilities. So we need to look at that as well. So we have done everything possible for our piece of building, our piece of building block. But when you interface with third-party building block, this can open up problems. So it's a question of whether we validate third-party components for security in a proper manner. And arrest any flaws in software design and architecture. So we look at the architectural flaws at early stages. So there are process that techniques we can use for them. So these are examples, right? So software security is all about, looking at pre-deployment activities, whereas application security typically is about looking at the post-deployment activities, which can be like post-deployment security test. So you deploy the system and try to test further. So those are some of the things. And capture, capture of flaws in software environment configuration. So we can do that later, right? Which is not good enough sometimes. And malicious code detection, patch and upgrade. That's something we do know. So when you find problems, you have to patch and upgrade. These are activities that happens after deployment, which is typically the security activities related to application security, when you say application security. And IP filtering, lockdown executables, and also looking at runtime to enforce software use policies. You may have policies which may not be implemented right properly. So you need to look at whether we are done properly and then fix them. So we see here, what we just seen in this diagram, application security we said is a build and patch approach. Is a short-term reactive approach, whereas software security is a holistic long-term approach looking at the root cause, doing things early so that we have less problems. Therefore, it's a proactive approach. So proactive approaches relate to pre-deployment activities, whereas reactive approaches generally relate to the post-deployment activities. So pre-deployment and post-deployment activities generally refer to those two areas actually. SSG or secure software engineering is having emphasis on application level because there are a lot of issues. Because almost all vendors want to reduce the security problems, and the typical approach is they try to build and patch. Sometimes security patches are released when they discover more and more problems, but it's a everlasting race with the with the malicious users, right? Because you try to find the problem, they find something else, so it goes on. So therefore, looking at the root cause than the symptoms is important. So the real cause of security vulnerability than the effect of the vulnerability. So we need to look at the root cause. If we fix them, we have less problems. So that's what is looking at, what we are looking at through SSC or secure software engineering, which we look at in the first part of our discussion today, in the handout actually, which we might have to continue in the next discussion as well. So because say some of the vulnerabilities that may lead to exploitation and it may lead to critical organizational information like that may come through various viruses and worms, for example, which will leak sensitive data or PWI, for example, personally identifiable information of our customers. So firewalls and IDS systems are no longer good enough. Just we need them, but they on their own is not good enough. So investing on a expensive infrastructure is not good enough. Building secure software is more important, probably, or very, very important as well. Because, for example, they cannot prevent attacks on their own. Like, for example, if there's a firewall, it cannot decide whether it's an input parameter which is valid or it's a code injection attack. So you may not be able to detect sometimes. So only the decision can be made by the application properly sometimes in some instance. So the attacks must be already eliminated during the development. The possible attacks should be possible problems has to be eliminated during the early phase of the life cycle actually. But in reality, unfortunately, the security aspects are paid less attention during the life cycle sometimes due to the time pressures in delivery schedules and whatever that can happen, because there's not enough, not sufficient attention given to the security dimension, what we are discussing here in some situations, because security development requires security conscious, well-educated software, architects, developers, QA engineers, etc. So that's why when it comes to this domain, we are talking about security throughout the life cycle by educating architects, developers, tech leads, everybody, project managers. So there is a need for this thing called as build security in simple words, security throughout the life cycle. So from early stages, the practices has to be brought in. So with the tools we refer later. So there are various examples. One research link shows that if you identify the problems at early stages, you can reduce the cost, in a significant factor. So it's a factor of 5 actually, 0.5 to 0.5 million to $2.5 million difference sometimes. And Microsoft, from a legacy operating system, Windows Vista, they have a claim when security was considered throughout the life cycle, the vulnerabilities were reduced by 45%. Actually, this build security paradigm was not something recently initiated. Microsoft has been using from Windows Vista days. So it was it was not a new thing for them. Subsequently, it has matured to various models. And so if you look at this one, when do we address the problem? Well, we have coding, unit testing, functional testing, field testing, and post-release testing, for example. Now, these curves, just indication only, shows what happens. So look at the magenta line, defects introduced in this phase. So you can see 85% of the defects are introduced in this coding phase. But as you go, there can be some level, but field testing also can, you do changes, so that can happen. So most of the problem happens in this curve at early phase. Defects introduced in this phase is that. But if you look at the orange color one, defects found in this phase. Okay, you introduce so much of problems in this phase, but these are discovered later. So as you go, the defects introduced will be detected, and post hopefully will go down generally. And the cost to repair the defect. So if you fix the problem early, typical curve actually, early stages is much less. But as you go further and further down the life cycle, the costs become exponential. So that's why we say trying to minimize the problems we see here to a great extent will reduce the cost as well. Right? So that will have impact on the schedules and the budget of the project typically. So in the upcoming session, we will see how we can bring or fuse security into waterfall life cycle, Scrum type, agile life cycles, and DevOps kind of life cycles. So there are some more slides actually in the first handout. Because our time, is over now. So we'll wrap up the session for today. But before I wrap up, do we have any questions? So we will be releasing the courseworks early, and we will publish the practical schedule by next week, so you can prepare how to take part in the practical sessions. And so we will publish in the timetable, update that showing when you will have the practicals, right? So we'll have the practicals early, so you can start on the coursework or the assignment early. So the whole idea is to learn. I mean, it's not just listen to me, but being able to understand these things and apply into real world situation is what we are looking at really, right? So learning those tools, which some of you may not be familiar, especially, is very, very important. Do we have any questions or clarifications you want to make? Right. If there are no questions, I think we can end the session, and thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Record